let's take a look at this problem. Maximum number of jumps to reach the last index from LeetCode. So in this problem, we are given an array and we are given another integer, that is target, and we have to find the maximum number of jumps to reach the last index of the array, and there are few conditions over that. The first one is I and j should belong to 0 and n range, and I should be less than j. The second one is the absolute difference between I and j should be between target or less than target. Now let us take a look at this example that is given in the question. So we have this array and the target is 2. So we have to find out the maximum number of jumps to reach the last index of this array, which is 2. So the condition is that the absolute difference between the jumps positions should be less than or equal to 2. So if we start at the starting position, that is 1, we can go to this position because the difference is 2, but we cannot go to this position because the difference is greater than 2. Also we cannot go to this position, or we can go to this and the last one. But if we go to the last one directly, the number of jumps will be counted to 2. So that will give us the minimum number of jumps but not the maximum number of jumps. So this is a classic TP problem, and we can solve it using classic bottom-up TP approach. Now talking about the solution approach, we will take an array of size n is the input array size, and initialize it to -1. This -1 represents that a certain position cannot be reached. Now we will take a loop and traverse from 0th position to n-1, and for each position we need to find out the maximum number of jumps encountered until now, and which also satisfy the condition that the absolute difference between two positions should be less than or equal to target. Let's try to code this solution. So first of all, we will take an array of size nums.size and initialize it to -1, considering that we cannot reach any position. So dpi represents the maximum number of jumps to reach ith position. Now since we are starting at 0th position, we will take the number of jumps to reach 0 is 0, and we will traverse over the entire array and we can start it from 1 because we have already initialized the 0th position. So we need to find out the maximum number of jumps for all the previous indices. So we will take j equal to 0 and j should be less than I. Now if two conditions are satisfied, first one is absolute of dp nums I and nums j is less than equal to target, and dpj is equal to -1. So first condition is the absolute difference should be less than equal to target, and the second condition is that the position should be reachable. In that case, we update ith position to be maximum of dpi and dpj plus 1. Finally, we just return the last index, which represents the maximum number of jumps to reach n minus 1th position. Let's try to run this solution. And it should be accepted.